Hello everyone, welcome back to another episode of Neurosci IQ. Today we are going to explore one of the brain's most fascinating signals, the P300 wave. We are going to be covering what the P300 wave is and why it matters. So let's get started. Before talking about the P300 wave, it is important for us to cover some basic definitions so that we can better understand the significance of these brain phenomena. Let's get started with the oddball paradigm. The oddball paradigm is one of the most common ways for researchers to elicit the P300 waves in the participants of a research study. So we can see here that in a typical oddball paradigm, participants are shown repetitive and non-surprising objects on, for example, a computer screen. In this case, it is like an apple, and they are going to be shown this apple a few times in a row so that it becomes not very interesting and not surprising. Suddenly, they will show another image, for example, a pencil or another surprising object that the participants weren't expecting. Next, the situation is repeated and we get another wave of apple sequences followed by a surprise element such as a pencil. As we can see, the participants' reactions will be not very surprising to the apple because apple is something that they expected to see as it was repeated multiple times. However, once the pencil is suddenly shown, they will be shocked, and this reaction to the pencil is what elicits the P300 wave that we will be covering. The other set of terminologies that we need to learn to better understand P300 waves are the letters and numbers that indicate the wave. For example, there could be either a P or an N. P would indicate that there is a positive deflection, which is indicated as a downward deflection on the EEG. Conversely, there could also be an N, which will stand for negative or negative deflection, and this will be reflected by an upward deflection on the EEG. Apart from letters P and N, there could also be numbers that follow these letters. For example, there could be N2, P2, and other combinations. The number is telling us, for example, it is the second negative deflection. For example, if it is P2, then it is the second positive deflection. And of course, P3, it is the third positive deflection. There is also other numbers that we have to remember. For example, P300. If the number is very large, of course, it is not telling us the position of the wave, but rather the milliseconds. For example, P300 indicates that it is a positive deflection that happens after 300 milliseconds. Now let's test our understanding. What do you guys think N100 would stand for? Well, the answer would be that N represents the negative deflection, and the 100 would be the negative deflection that happens after 100 milliseconds. And you can see that this is true from the diagram. Now that we have covered some basic terminologies, we can start moving to talking about P300 event-related potentials. So an event-related potential, or an ERP, is basically a brain response to a specific sensory or cognitive or even motor event that is detectable as a voltage change in EEG data. And here is a picture of William Walter, who was a leading figure in studying brainwaves using EEG. So as we discussed, P300 is a positive deflection as detected by the EEG and happens after 300 milliseconds. And an event related potential doesn't have to be visual in nature. It could be auditory or even tactile. So for the oddball paradigm that we discussed with the apples and the pencils, it could also be elucidated by auditory or like sound waves or even a tactile tasks. And these are all things that will elicit a P300 wave in participants. Furthermore, event related potentials are detected by EEG. And what happens is in a research setting, participants are asked to put on the electrodes so that the scientists can detect the electrical patterns that is happening when they perform the tasks so that they can better understand the participants' reaction to a certain stimuli, which is essentially what event related potentials are. Moreover, it is also important to note that there is multiple different event related potentials and each of them are of different significance. For example, we have P300, but we also have N100, P600, and all of these are significant due to different reasons. And there are many different scientists working and dedicating their careers to studying any of these different event related potentials. Furthermore, event related potentials, as we will see, have been used in clinical research to try to diagnose patients, to help with diagnosis of patients with a wide variety of neurological conditions such as ADHD and schizophrenia. So now let's get more specific and talk about P300 event related potential. As we discussed, P300 ERP is related to the cognitive processing and attention span of the subject. Furthermore, as the name suggests and we discussed, P300 is a positive reflection that happens after 300, approximately after 300 milliseconds. There has been two different subcomponents of the P300 that have been investigated, and the first one is the P3A, which as the name suggests happens earlier, and the second one is the P3B, and as the name suggests it happens later. So as we got to understand, the P300 wave is often elucidated by the oddball paradigm in a research setting, but this is also something that is unique to everyone, and everyone has their own unique signature, or as I like to call it, fingerprint for P300. And as you can see from the diagram, that's from 9 different participants, and each of them have their own unique fingerprint of P300 waves. And while the general shape and the timing is related to each other, everyone experiences it a little bit differently, and this is what makes it very interesting. Furthermore, P300 has many different applications that are currently under investigation and being researched by scientists. The first one is brain-computer interface, and the second one is related to cognitive and psychological research, which is something that we will cover in the next slide. So now let's turn our attention into some of the applications of P300 that we discussed. Let's start with the brain-computer interface. Brain-computer interfaces, or BCIs, are essentially systems that facilitate a direct communication pathway between the brain and an external device such as a computer. Essentially, BCIs translate brain signals into commands that can control computers or other devices, such as prosthetic limbs, enabling interaction without any physical movement from the user. This is very beneficial because it is very significant for individuals with severe motor impairments, as it offers a means to communicate and control their environment using their brain activity or neuronal activity alone. So essentially, P300 has been used to facilitate this direct communication that brain computer interface involves, and this has allowed a wide variety of functions, at least in a research setting. For example, controlling prosthetics, wheelchairs, and even computers themselves, which has made these technologies a lot more accessible. While there are many different types of brain computer interfaces, the P300 has many key advantages. The first one, and perhaps the most important one, is that it is non-invasive, because some technologies actually use invasive surgeries to implement electrodes, which is something that many participants are hesitant to do. Another advantage of the P300 brain computer interface is that it is easy to use and it is not complicated, nor does it require substantive education or learning prior to the implementation, so that the subjects can just watch a video for a few minutes and they are good to go. Another thing that I want to talk about is, as we can see from the diagram, it essentially involves the brain computer interface. It specifically involves the signals getting picked up by the EEG device, such as the P300 signals that the neurons generate. And these signals are first, after getting picked up, are processed, and the meaningful patterns are identified by the machine, and these are then used to activate or initiate a response in the external device. However, it is also important to note that there are many different applications of brain computer interface, and apart from improved quality of life and accessibility, some people have actually tried using the P300 wave for entertainment purposes. As you can imagine, it has a very key role in, for example, virtual realities or even controlling characters in a video game. Now let's talk about some of the applications of the P300 apart from brain-computer interfaces. P300 has been really significantly studied because it allows researchers to investigate the neuronal mechanism underlying cognitive changes, and also study the impact of aging, development, and even different psychological states, which is very useful from the perspective of a researcher. Secondly, the P300 can also be used to elucidate brain activity and the neuronal mechanism behind attention and information processing, so that we can really better understand these phenomenons and improve our understanding. And thirdly, the other research application is that we can actually use the P300 to track the recovery progress of patients who have gotten brain injuries or suffered from a stroke, and the P300 can be used to see how they are doing in terms of recovery, as these conditions such as a stroke really interferes with the P300. Lastly, there has also been a lot of noise from the research community about using the P300 to helping doctors diagnose neurological conditions such as ADHD and Alzheimer's disease, and these could hopefully be used in the future in a clinical setting. Lastly, let's talk about the factors that impact P300. As we already discussed, each individual has a slightly different P300, but there's also different factors that we should also be aware of. For example, increased age increases the latency of the P300, but increased age decreases the amplitude of the P300 wave. Secondly, neurological conditions such as Alzheimer's disease or schizophrenia or even ADHD have been shown to influence the P300 wave. Also, the stimulus properties also impacts the P300 wave. For example, in the oddball paradigm, the more shocking the target stimulus, the higher the amplitude of the P300 wave that is elicited by the paradigm. Lastly, psychological state of the participants also plays a huge role. For example, if they are awake, if they are sleepy, or even under the influence of alcohol or other drugs, the P300 wave will be impacted. So, if you like this episode, please make sure to like and subscribe for more similar content in the future. Thank you for listening.